Welcome back. In this video, I will show you how to use fixed size arrays in a C++ program. So far, we've seen how to store a single value within a variable. Now let's see how to store more than one value using an array. Let's begin by looking at an example. Here I'll show you how to declare an array of size 4, which holds 4 integers. So the data type is int, name of the variable is array, and within square brackets we specify what is the size of the array. The size here is 4. So for fixed size arrays, we need to specify the size of the array when we are declaring it. The reason why this is because during compile time, the compiler will allocate enough memory to store all the elements that we want to store in this variable called array. Next, let's see how to access an element within this array. To access an element in the array, we can again use the square bracket operator. So here array in square brackets I will access the ith element stored within this array, and I'm printing the value stored at the ith position using stdcout. So in this for loop, we will access each element stored within the array and print its value. Now let's see what will be the value that will be stored within the array. Will it be 0000? That is, will C++ initialize the array using 0000, even though we've not provided any initial value? Will it be 0124 or will it be something random? So let's see what will be the value stored. Now notice the value stored at the four positions of this array are all random values. So since we did not initialize this array, we are looking at some uninitialized memory which holds some random integer. Now let's look at different ways of initializing an array. There are a few different ways. So first, let's begin by looking at the most simplest way, where we will access each element of the array and modify its value. So to change a value of an array, element of an array, the syntax is the same. So array followed by square brackets and the index which we want to modify. Here I want to modify the 0th element and store 10 instead of the current value that is stored at index 0. Similarly, at index 1, I want to store 30. At index 2, I want to store minus 0.5, converting it to an integer using static underscore cast. Finally, at index 3, I want to store 1 int 10 to the power of 5. Now let's print the array again. Let's see what will be the values stored at each of these 4 different positions. Will it be 10, 30, minus 0.51 times 10 to the power of 5? Or will it be 0000, or will it be 10, 30, 0, and 100,000? So let's continue the execution and let's see what is the value stored. Notice the value stored is 10, 30, 0, and 100,000. So this minus 0.5 is converted to an integer using static cast. So only the integral part, which is 0, is stored at the second position. Now let's see what happens when we try to access an element that is outside the range of the array. So we know the array size is equal to 4, and here I'm trying to access the 5th element using index equal to 4. And I'm trying to write this value dead, which is in decimal 57,005. So let's continue the execution and see whether C++ allows us to do this. Notice the value stored at position 4 is equal to 57005. So this worked, but this is not true always. So sometimes we may not have enough memory to write that particular value, or probably we will change something else stored at that particular location, which is not intended, right? So this can cause undefined behavior, wherein we are trying to overwrite a value at a memory location which we have not which we are not allowed to write, right? So we've only allocated memory for 4 integers and we are trying to write at the 5th location. Now let's see what happens if we modify this index variable to a const. So if we add a const qualifier and define this variable as a const, what happens? Will the program now compile, or do we get a compilation error? Now notice we got a compilation error, and the error says that we are trying to access the 5th element and writing to an array which is of size 4. So the reason why this gives an error and not the other one, where the const without const we saw that the program executed without any errors. The reason for this is because when the index is const, the compiler knows at compile time that we are trying to access the fifth element and write into it. And it also knows that the size of the array is only 4. And therefore, it flags us this error saying that we are trying to access an element that is outside the range of the array. So similarly, we can check what happens when we try to do this. Here, I'm trying to access the fifth element of the array using index 4. And this should again fail. This should not compile. Because 4 is a constant, and at compile time, the compiler knows that we are trying to access an element that is outside the valid range. Now, if the index is not constant, then at runtime, we need to check whether the index is within the range and write or read only if it's within the range. Next, let's look at some examples of initializing the array with an initialization list. So here I'm declaring an array of type double, size is again 4, and within braces, I'm initializing the array with 4 different values. The values are 0.1, minus 42, 3.14, 159, and minus 1. Okay, so this is good. So there are 4 positions and we provide 4 different values. Now let's see what happens if we just give a single value. Here, I'm declaring a new variable called maybe_initialize array, and I'm only giving a single value 0. So the question is, will the remaining 3 values be all uninitialized and random? Will they all be initialized to 0? Or do we see something else? So here, the option is the same as the sequence that we used to initialize the previous array. So let's now execute this program again, and let's see what will be the value stored within that array. All right. Now notice the value stored within this array maybe_initialized array is all zeros. So even though we specify only 1 0, the compiler initializes all the values with the same value equal to 0. Now let's look at a different example. Here again the size of the array is 4, and we're only initializing the first 2 values, 0, 1. So the question is, what will happen to the remaining 2 values? Similar to before, will the compiler repeat the same values again? So the first option is 0, 1, 0, 1. The second option is, will the last value be used to initialize the remaining values? So will it be 0, 1, 1, 1? Or will it be something else which is random, or will it be 0, 1, 0, 0? So let's continue the execution and let's see what is the value stored within the program. Now the value stored in the array is 0, 1, 0, 0. So the remaining 2 values that we did not specify what the initial values are initialized with 0. Now if we want to simply initialize all the values of an array with zeros, we can use this trick of just providing 2 braces on the right hand side without any value. C++ will automatically initialize all the values with zeros. Now next, let's see how to declare fixed size character arrays in a C++ program. So here I'm declaring a variable called input in line 108, and its type is file name. So we will see what file name is. On the right hand side, we are initializing it with a string. Now in practice, we will not use fixed size character arrays. We will instead use std string, which we've been using since the beginning of this class. But this shows you an example of how to do this with fixed size character arrays. Now at the beginning of the program, I've used this keyword called using to create a few aliases. So here, instead of writing a character array of size 16, we can write its alias file name. Or instead of writing an integer of size 8, we can use its alias myArray. So wherever you use file name, the compiler will replace with character of size 16. Wherever we use myArray, the compiler will know that we want to declare an array of size 8, which is of type integers. Now let's go back and let's see what will be the value of input that will be printed after this line is executed. Now notice array is the value that is printed is array.cpp, which is good. Now let's see what happens when we try to write a bigger string. So here we know that 2_much is a variable of type file name. File name can only hold 16 characters, but I'm trying to initialize it with a value which is more than 16 characters. So in fact, here it is 20 characters. So let's see what happens. Notice this program doesn't compile. So at compilation time, the compiler knows that we are trying to initialize this array with a string that is larger than what is the size of the character array that holds it. So instead, if we change the type here from file name to std string, this code should compile now. So std string again is a resizable array of characters. So we can hold 20 characters in the variable 2_much when its data type is std string. Now let's declare an integer array of size 8 using myArray. So numbers is now same. So the declaration myArray numbers is the same as declaring int numbers and in square brackets 8. And I'm initializing this array with this for loop, wherein I'm initializing each value of this array with the index at which the value is stored. And next, let's see how to pass this variable array into a function and compute the sum of the values stored within this integer array. So here I've written a function called sum. It takes two parameters. The first is the array. The second one is the size of the array. So size here is 8. Now let's see what is the definition of this function. Now, even though we are passing the size of the array as a parameter to this function, we don't have to actually do this. We can compute the size of this array using the size of operator. So the syntax is, first we provide size of the data type. The data type is int with size 8. And then we can divide it by size of each integer. So size of computes the size of a variable in bytes. So we need to divide it by the size of how many bytes an integer is. This also computes what's the size of the array. So when we execute this program, we will see the size of the array. It should be again equal to 8. It should be again equal to 8. Now within this function, I've declared a variable called sum, initialized it to 0. And within for loop, I'm just incrementing this variable with the value stored at each position of this array. So at the end of this for loop, this variable sum should hold the sum of all the variables, all the elements stored in the array. So let's run this program now again, and let's first use the watch window to check whether the numbers variable is initialized properly. Notice the initial value is 0, 1, 2, 3, 4, 5, 6, 7. Now let's call this function. And let's see what is the size. Here I'm printing the size using the size of operator. Notice the size is 8, so we don't have to actually pass the size. And at the end of the loop, let's confirm what is the sum. So the variable sum, if we go back to the watch window, we can check the value is equal to 28. So outside the loop, I was printing the sum of the array numbers, so we should see 28 here on the console window. So the sum of the arrays is again 28. So this showed you how to pass an integer array to a function and then compute the sum of all the elements stored within the array. So this concludes the topic on arrays. Next time we will pick up strings and we will look at strings more closely and what different operations we can do with strings. Thank you.